What's up, Raiders? So I just wanted to make a little video here to go over the Google slide that is in preparation for our angle pair equations quiz. So it's the one you see right here on the screen, the angle pair equations practice problems. So again, the learning target here, I'm learning how to create and solve equations to analyze angle pairs. And before I forget, embedded into this document on slide 2 is a video I've recorded separately with just a general explanation about some angle pairs and their equations. So don't forget, as you're working on these, besides this video and just doing your own work, you can also use this embedded video on slide 2 to help you out as well. So as we work on creating and solving equations to analyze angle pairs, remember that while there's 6 different angle pair types, there's only 2 possible categories that can be true about their angle measures. Either the angle measures are equal to each other if the conditions are right, or the angle measures are supplementary and add up to 180 degrees if the conditions are right. So just as a couple of quick examples of how this could show up, if you had, say, vertical angles, like angle 1 and angle 2, these are always traits. Vertical angle measures are always equal to each other. So the angles themselves would always be congruent. So you can kind of say that angle 1 is congruent to angle 2, the actual physical things. They're congruent to each other. Or if you're describing their measurements, you could say the measure of angle 1 equals the measure of angle 2. So anytime you're looking at an angle pair, if their angle measures are equal to each other, you literally set them equal to each other with their algebraic expressions. Another scenario, let's say angle 1 and 2 here, well, that setup, they're a linear pair. Linear pairs always add up to 180. They're always supplementary. So we would not be able to say that angle 1 is congruent to angle 2 necessarily, but what we can say is this: the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Every single angle pair that we're working with, if the conditions are right, has to fall into one of these 2 categories. Either the angles measures equal each other, or the supplementary and add up to 180. Keeping that in mind, let's dive into these problems one at a time. Well, here we are. Similar to what I just put on the smartboard, these are vertical angles. So we know vertical angles are always congruent. Their measurements are always equal. So we can go over here and create that equation. The expression for the angle measure on the left is x plus 16. Give you a little space here just so it's not too visually cluttered. X plus 16, that's the measure for the angle on the left. And then the expression for the angle on the right is 4x minus 5. 4x minus 5, and it's that many degrees. So you've got to solve this equation. So notice that you have x's on both sides of the equation. It does not matter if you put all your x's on the left or all your x's on the right. It does not matter as long as you put them all together. Now, just because, like most people, I prefer to avoid negative numbers, so I'm going to bring the x over the right side to keep it in a positive amount. So the way to get rid of x, subtract x from both sides. So now we have no idea what x is, but if you have x and then you subtract x, that cancels out. That's why we did that. So the only thing remaining on the left side is 16, and that equals, we don't know what x is, but if we have 4 of them, and then we subtract 1 of them, we've got 3 x's remaining, minus 5. So we're one step closer to isolating that variable x to get it all by itself, to get x equals. So we have to undo everything that's happening to the x. So going in reverse order of operations, reverse PEMDAS, x is being combined with the 5 where it has 5 subtracted from it. So the opposite then is going to be adding 5. So we're going to add 5 to both sides of the equation. So on the left side, 16 plus 5 is 21. And 3x, 3 times some unknown number, we still have that. And then if you subtract 5, but then right after that you add 5, that cancels out. That's why we did that. So we have 21 equals 3x. So now we're one step away from solving for x. We want to get x all by itself. We want to isolate that variable. So ask yourself the question, what's happening to x that I have to undo? Well, how is the x being combined with the 3? They're multiplied. X is multiplied by 3. So the inverse operation, or opposite of multiplying by 3, divide by 3. Now, logistically, it's a little annoying to show the work of dividing both sides by 3, so I'm just going to kind of put it in parentheses here. divide both sides by 3. If we're doing this by hand, I would write the division symbol and I'd physically place the 3 in the denominator for each of them, but divide by both sides by 3 in parentheses, that gets the job done. So now this becomes 7 equals x. Now we're not done, but we've at least gotten to the point that we now know what x is. And now that we know what x is, we can substitute that value into each expression to figure out the angles. So the angle on the left was some unknown number x plus 16. Well, it's no longer unknown. It's 7 plus 16, which is 23 degrees. And let's do the angle on the right. Well, the expression on the right is 4 times some unknown number minus 5. Well, that becomes 4 times, it's no longer an unknown number, it's 4 times 7 minus 5. Well, 4 times 7 is 28. So 28 minus 5 is 23. And that should make sense because we said at the beginning, vertical angles, their measures are the same. So lo and behold, they're 23 degrees and 23 degrees. And again, keep in mind what we talked about with all our angle pairs. If the conditions are right, either the angle measures equal each other, like we just did, or they're supplementary and add up to 180. It's got to be one of those two categories as long as the conditions are right. So let's go on to the next one here. Well, if we look at our angle pair here, they're alternate interior angles. And we can see with the arrow tips in the middle of these lines, so we know these lines are parallel, so the conditions are right. In the alternate interior angles theorem, if the two lines intersected by the transversal are parallel, which they are, then alternate interior angles are congruent. That means their measures are equal. So we're going to end up with the same equation format as that we had in the last one. So the angle in the top left, 4x minus 10, that angle measure has got to equal the other one. In this case, we actually know what it is, 58 degrees. So this one's actually easier to solve than our last one. All our x's are already together. So we just have to isolate that variable x, get it by itself, undo everything that's happening to it. Well, reverse order of operations, reverse PEMDAS, has 10 subtracted from it. So the way to undo that, the inverse of subtracting 10, add 10 on both sides. So 4x minus 10 plus 10, well, minus 10 plus 10 cancels out. That's why we did that. So now we have 4x equals 58. So now we only have one step left. We want to get x by itself. It's currently being multiplied by 4. So the way we undo that, we do the opposite, the inverse operation of multiplying by 4, divide by 4. So we're going to divide both sides by 4. So now 4x divided by 4, well, any number divided by itself is 1. So 1x, that's why we did that. So the left side is just x. And then 58 divided by 4. Excuse me, I just realized I made a mistake there. 58 plus 10, I forgot to do that part. So it's 4x equals 68, my mistake. So 68 divided by 4. So x equals 17. Sorry for that mix up there. So if we look in where we're providing our final answer here, x equals 17. And then now that we know what x is, we can substitute it. 4x minus 10 becomes 4 times, it's no longer an unknown number, it's 4 times 17 minus 10. Well, 4 times 17 is 68 minus 10. So that means that angle on top is 58 degrees. And that should make sense because these alternate interior angles, we said at the beginning, they were going to be congruent to each other. Their angle measures are equal. So if the one on the bottom right was 58 degrees, then the one on the top left's got to be 58 degrees. Okay, moving on. Now I've got a linear pair here. And just thinking logically, keep in mind that the angle pair equation formats are going to be, if the conditions are right, either the angle measures equal each other or they're supplementary and add up to 180. It's got to be one of those two. So thinking logically, if you look at x minus 10, if you look at that angle, you don't know how many degrees it is. That's what we're trying to figure out. But visually, you can tell it's less than 90 degrees. It's a cube. And look at the angle up top, 4x plus 20 degrees. Again, we don't know how many degrees it is specifically yet. We'll get that soon. But it's obtuse. It's more than 90. So in terms of the two possibilities, either the angle measures are equal to each other or they're supplementary. Well, if one angle is less than 90 and one angle is more than 90, there's no way they can equal each other. So it's got to be the other thing. They're supplementary. They add up to 180. And lo and behold, linear pair, if you put them together, they make a straight line or segment, which is 180 degrees. So now our equation is a little different than the last two. They don't equal each other. They add up to 180. So it becomes 4x plus 20 plus the other angle measure expression, x minus 10. So what we have here is we've added together the two angles, and collectively they're supplementary. So that means they equal 180 degrees. So we got to combine our like terms. So we have no idea what x is, but we have four of them, and then a little bit later we have another one. So we have 5x. And then our constants, you got to pay attention to the signs. It's positive 20 and negative 10. So it becomes 20 minus 10. So it's plus 10. Combine our like terms, 5x plus 10 equals 180 degrees. So now we have to get x by itself. We want to isolate that variable. So we have to undo everything that's happening to x. So we're going to go in reverse order of operations, reverse PEMDAS. So right now, the fact that x has 10 added to it, to get rid of that, we have to do the opposite. So the opposite of adding 10, subtract 10 from both sides. This now becomes 5x, that's the only thing remaining on the left side, equals 170.
Hello, everyone. I hope you
So now, at this point, we want to get x all by itself, so we're going to divide both sides by 5.
That we have a staff meeting as soon as paralysis, as well by 2:15 on a Zoom link. At this time, walkers and drivers may be dismissed.
So 170 divided by 5 is 34. So we're not done, but now we can substitute that value for x into each expression. So the angle up top, 4 times some unknown number x plus 20. Well, that becomes 4 times 34 plus 20. Well, 4 times 34 is 136 plus 20. So that angle up top is 156 degrees, which very generally that matches up with what we kind of analyzed at the beginning. We could tell visually it was obtuse, it was more than 90. So now do the same thing for the other angle, x minus 10. So that becomes 34 minus 10. So that's a 24-degree angle. And now just kind of a quick check. Now that we've figured out each angle measure individually, add them together, 156 plus 24, lo and behold, equals what it should, 180. Because again, we said at the beginning, these angles are supplementary. So the x minus 10 algebraic expression meant that that was a 24-degree angle. And the 4x plus 20 algebraic expression meant that that obtuse angle is 156 degrees. Okay, last problem.
Student time buses 26, 27, 28, and 29 may be dismissed.
So these are same side interior angles. And as long as the conditions are correct, meaning the intersected lines, in this case L and M, are parallel, then there's going to be something true about these angle measures mathematically. Now notice there's no visual symbol with arrow tips in the middle of the lines telling us they're parallel, but if you look at the directions themselves, determine the measure of each labeled angles, lines L and M are parallel, it's told to you there. So it's just another way to communicate it.
58, 62, and 53.
So now if you look here, again, you got two possibilities. Either the angle measures equal each other or they're supplementary. It's got to be one of those two things. So thinking logically, if you look at the 2x plus 4 measurement up top, you don't know how many degrees it is, but it's acute. It's less than 90. And look down below at 12x plus 8. We don't know how many degrees it is specifically, but it's obtuse, more than 90. So there's no way an angle less than 90 can be equal to an angle more than 90. So you can rule out
30, 31, 32, 33, and 34. Have a wonderful afternoon, everyone.
So you can rule out the possibility that the angle measures equal each other. So the only thing left is they're supplementary. They have to add up to 180. So that's how we can write our equation. 2x plus 4, that's the algebraic expression for the angle on top. Add to that the algebraic expression for the one on the bottom, 12x plus 8. Collectively, those two angles have to add up to 180 degrees. So we're going to combine like terms. But we have no idea what x is, but we have 2 of them. And then a little later on, we have 12 of them. So now we have 14x. And then our constants, the 4 and the 8, they're both positive. So that becomes plus 12 equals 180. So now we have to isolate that variable x, get it all by itself. We have to undo everything that's happening to it in reverse order of operations, reverse PEMDAS. And x is being multiplied by 14. It has 12 added to it. So go in reverse order of operations to undo all this. The opposite of adding 12, subtract 12 from both sides. Now this gives us 14x equals 168. So the last step, x is being multiplied by 14. So to undo that, divide by 14. So divide both sides by 14. And we're going to end up with x equals, now 168 divided by 14 is 12. So now that we know what x is, we can substitute that value into each angle measure expression. So 2x plus 4 becomes 2 times, it's no longer an unknown number, it's 12. So it becomes 2 times 12 plus 4. Well, 2 times 12 is 24. 24 plus 4. So that's a 28-degree angle. Now we'll do our other algebraic expression. 12x plus 8. That means 12 times some unknown number, but now we know what it is. That unknown number is 12 plus 8. Well, 12 times 12 is 144. 144 plus 8, so that's 152. Now we can just kind of quick check our work. One angle is 28 degrees, the other one's 152 degrees. Add them together, lo and behold, 180 degrees. Like we said it was at the beginning, so they were supplementary. So the 2x plus 4 angle was 28 degrees, and the 12x plus 8 angle is 152 degrees. All right, hopefully you found this helpful. If you have any questions, like always, send me an email or contact me on the Remind app.